This is what the backside of my garage looked like before the expansion. And this is what it looked like with some of the concrete forming and the fiberglass rebar. We had to do a bunch of excavation work. This slab was really expensive. Here's another close-up with the fiberglass rebar. And we also put a trench drain in as well. This is looking off the backside of the existing garage. The slab is 50 feet long and 30 feet wide. It's 8 inches thick, I believe, in the center, and the edges are reinforced and thicker. This is looking off the backside where that excavation was done. And we used tip-up wall construction. This is the south wall, the first big wall. And here's another picture of that wall up. To lift the walls up, we used these cable-operated wall jacks, they're called. Here they are on Amazon. They made the job really easy. You connect this cable to the top sill when the wall is on the ground, like this, and then you ratchet it up and it lifts the wall up. It makes the job very simple. Here's all 3 new walls in place with some of the bracing still intact. And here's from the south side looking inside. This is looking out the existing garage. It looks freaking massive. Here's another picture showing the new trusses before we had the ceiling done and before it was painted, before the shingles were installed. This is the truss I designed. It's a new truss design. I'll talk about it later. I transported the roll-up door using my 4Runner. It weighed over 350 pounds. It was a beast. And I did it myself. I used ratchet straps. It took me an entire day to get this thing hung. But once it was hung and open, it looks really nice with no tracks in the way. This is the backside painted with the shingles installed. Here's the new custom truss design. It's a traditional scissors truss, except for it has these flat sections on the side to make it easier to set the trusses. A normal scissors truss would just taper towards the edges, and it would be difficult to set them on the top sill. This makes them easier to set. There's also this flat spot at the top for mounting lights. I insulated the walls with a friend of mine, and we were kind of chasing down winter. It was November when we were doing this. This is R30. It was a pain to install this. We used electric staplers from Milwaukee Tool. I hired somebody to rock everything. They used 12-foot sheets. This is after the mudding. And then we bought an LVL 3-ply beam. We made a false wall where the old wall used to be and basically turned it into a giant door header. This is nearly the finished product. It's rocked, painted, LED lighting. Here's that beam with that wall all opened up. There's 220 volt power for a mini split. This is from inside. It's huge. It's basically a 9-car garage. I think it's around 1,600 square feet. This beam is 18 inches tall, and it's probably stronger than the wall that was there before. It's pretty hefty. We're rocking this beam and finishing it. I'll show it in a few minutes here. The amount of room we gained was awesome. These white tables used to take up like half my garage. I've gotten so many requests from my YouTube channel to help people with their garages, and I've helped a lot of people, but I just don't have the time to focus on a lot of these projects. So I wanted to make this video to basically show you how to make your own truss, or maybe modify your own garage, and just some of the major things. The point of a truss is, see how it's sloped? It's so things don't stay on your roof. So rain and snow will fall off the roof, especially when sunlight hits the snow and it starts to melt. That's why it's sloped the way it is. If it was flat, you'd get a buildup of stuff on top of your roof and it would slowly start to degrade over time. There are buildings that do have flat roofs, like CMU or cinder block construction. They'll often have flat roofs, but they have membrane roofs and they often have to be maintained and they degrade as well. So a normal residential application, you'll have these sloped roof lines. What people normally want to do is they just want to remove the bottom cords, and this is an example of a scissors truss. So there's already a little bit of vertical room in here, but if you try to delete these and just cut them out like this, what would happen is you'd have a load that comes down on top of here, and it would tend to spread the walls out. So it would flatten this triangle and your walls would push out. And that's why you need this horizontal bracing to prevent the walls from pushing out sideways. You definitely need that in almost every truss application. There's something called a collar tie that can go across like a third of the way down, and it's a horizontal piece that stiffens the truss up pretty significantly, but you want it as low as possible. And that's why traditional trusses have that horizontal lower collar or lower cord all the way across, because that's where it's strongest. The strongest truss, if you think about it, is a solid piece of wood. So if you took this truss and then you put plywood backing all around on this whole face and made a giant triangle out of plywood, that's basically the strongest truss. It is the strongest truss. The problem is it's not light and it's not optimized for, you know, the strength to weight ratio. Here's the modification that I made. I bumped the back of the garage out 30 feet here and tied into the existing roof line. This is called a roof on roof construction, where we hit the existing roof at a perpendicular angle and tied in to it using stick-built construction. And here is that truss I showed before. This is just the outer pieces of wood. This doesn't show the inside members. I drew the exact dimensions I needed, and then I double, triple checked. Well, actually, we probably measured like 50 times to make sure we had the dimensions exact. And then I had a company actually make the trusses for me, and I'm going to show you how to do that yourself in a second. But this is the drawing they provided, a very accurate engineered drawing, and you can take this to a company that manufactures trusses, like a lumber yard, and they can make engineered wood trusses for you. Before you think about modifying your own trusses in your garage, I highly recommend doing this. This did not exist a couple years ago when I made my first couple garage videos. Search Menards truss designs. Menards is a store in the Midwest, but it's okay. Even if you live in California or on the coast, you can still use their website. So Menards, go to truss. And the good thing is that since they're in the Midwest, they make trusses for areas that have a lot of wind and a lot of snow and ice load. Go up here, start designing. And I'm just going to use my zip code, 53228. Hey, you can use my zip code if you want. We get a lot of snow, so anything that's built for this condition is probably going to be okay for the rest of the country. Select a store, design your own truss, go up here to residential, and then you can pick what kind of truss you want. There's a bunch of different kinds, and the kind of truss that I've been using in my videos is the scissors truss. I like how it affords the extra vertical room for car lifts, and it's still a really strong truss design. And the loading conditions are shown here. If you don't know anything about this, just leave it. They're probably all right. Continue to enter specs, and here is the designer. It's really cool. I'm not joking. I use this for my construction. You can pick the span. Say you want a 30-foot span, and it will widen it for you. You can change the pitch, and it won't design things that are weak or that are out of bounds. I would show you, but if I did, I think it crashes sometimes, so I'm not going to show you. But you can change the pitch. For example, I can change this pitch to a 312 and make it flatter, but then it gets thinner and you lose some of the strength. But you could also do something like a 612 or something crazy. Get this huge cathedral, and then you can do the inside and the outside, so you can bump up this center portion as well. You can go 412 in the center. I'm gonna go back to what it was before though. And once you have your pitches figured out, you can also do the inside clear height, and that's the height of your walls. Let's say 10 feet. And this doesn't change the calculations, it just changes this visual representation. And then you can do a quantity. Let's say 10 or 15. And this even allows you to design ends. You can do a standard end. And this is a traditional truss on the side. But it's awesome. You can zoom in and go inside of the building and see inside there. And then you hit continue. And you can print your spec sheets right here. So it's giving you all the essential design details over here on the left. And with your spec sheets, you have an engineered drawing that you can print off and bring somewhere locally with the exact dimensions you need. Man, as much as I wanted to teach you guys how to do trigonometry, the law of sines, I think this is the easier way of doing it. Just design the truss on the Menards website, get it close. And if you want to do that custom truss that I did, this one, I'll include the documentation for that in the description of this video. This, again, allows easier setting of the truss on the top sill of your walls. And here's some more of those fun calculations that I was eager to show you, but technology caught up with us and Menards has come through. If you're still motivated and you want to build your own truss, you can design it on the Menards website. get the dimensions, and then you can buy these mending plates, these metal plates, and put the wood together and then attach the pieces of wood with mending plates. This is not an exact science. Some of the mending plates were falling off the trusses by the time they arrived at my house. This is the end result. It's nice, big, bright, white. It's around 1,600 square feet. There is so much more room. There's over double the room that there was before. I have room to work on engines, room to set up tables, stain trim. There's still a little bit of molding left. This is the original portion of the garage where I modified the trusses into scissors trusses in my original video series. And as you can see, we got a bunch more room. I could not be happier with the end results. This allows us to pull cars forward after working on them in the bay and set up a bunch of different projects and experiments. It's awesome. If you're not a subscriber to my channel, please consider subscribing. It helps me out a lot. Thank you so much for watching my video.